Welcome to the live classroom of pharmaceutical engineering. And in this class, I'm going to teach about the topic Colloid Mill. The Colloid Mill is one of the important mills which plays a very important role in the solid dosage forms, especially in the tablet coating section area. Let us see the various components of the Colloid Mill. The Colloid Mill consists of a dome-shaped rotor, which is having a series of ports, and this dome-shaped device is being fastened to a shaft. So this is the entire unit known as a rotor, which rotates on its own axis. And here you have two shafts on either side of the rotor, one here and the second one here to the right hand side. These are the two shafts which are present on either side of the rotor. And here you have this blue colored one is the recycle pipe. And here this conical shaped steel vessel is the hopper for the entry of a feed inlet. And here this is the outlet for the feed material. So these are the various components of the colloid mill. Now let us see the working of colloid mill. So the colloid mill is mainly used for size reduction of emulsions, suspensions, and liquid dosage forms, where the fine particles which are present in the liquid dosage forms are size reduced. So the main principle involved in colloid mill is attrition. Attrition is the important principle that works with the colloid mill. Let us see the working of the colloid mill. So the feed material is placed through the hopper and the machine is run. And once the machine is run, the rotor starts moving at high speed. So once it is being run at high speed, because of the dome shape, the material falls onto the dome shape and it travels along the ports which are present grooved onto the dome shaped rotor. And these ports will make the solution to spill onto the walls of the colloid mill. Because of the high speed of the rotor, it produces a centrifugal force and makes the material to spill onto the walls. When it is spilled, it is thrown to the walls and it passes between the colloid mill wall and the rotor and passes between the rotor and the colloid mill and again in between the rotor and the stator. So here by adjusting the distance between the rotor and stator, the fineness of the liquid preparation grinding can be carried on. So here, once the material passes, it comes out and again it goes through this recycle pipe and again falls into the hopper and the cycle is repeated. Likewise, the cycle of size reduction process is carried over several number of times, and if you have to test for every frequent amounts of intervals of time to see whether the desired product has reached its fineness or not. So once you think that the output is sufficient for you to get the desired particle size reduction has taken place, you stop the process and you can able to use the feed outlet pipe for collecting the size reduced solution preparation. And here before collecting you can able to fix a filter to the outlet pipe. Thereby what happens is you get the filtered feed which is very much clear and polished in nature. So this is how the working of colloid mill will result. And let us see the real picture of colloid mill. Can you see here? This is how the exact colloid mill in a pharmaceutical industry looks like. So this is a industry scale model. And here, if you see here, this is the steel vessel, which is a conical one, which is known as a feed hopper. And can you see here, this is the place where the rotor exists. The rotor, as I told you, that it can be used for adjusting the gap between the rotor and stator. So if you hold these two handles and if you turn in clockwise direction, you can able to reduce the gap between the rotor and stator. If you turn the rotor in anti-clockwise direction, the distance between the rotor and a stator can be increased. So this handle will help in moving the rotor either in clockwise direction or anti-clockwise direction to adjust the distance between the rotor and stator. So where do you find the stators? So this is the point where you'll find the two stators on either side of the rotor. And can you see here, this is the pipe. Can you see here that after the solution is subjected to size reduction, it will pass through the stators. And can you see the pipe over here? It is being connected over here and it moves through this recycled pipe, and again it falls into the hopper, and again the process is repeated. So this process is repeated until you get the desired size reduced material. Okay, so here you have the lock key. Once you lock it, it will be having a cyclic phenomenon. So cyclic number of cycles, the liquid preparation is subjected to size reduction. Suppose if you open it, what happens is the material will come through this feed outlet, and you can able to collect the solution into the feed bucket. And here if you see as the rotor, this, as I told you, that the rotor is a dome shaped device. And can you see the grooves that were designed onto the conical dome shaped device? So these devices are grooved in such a way that they give channels. Channels are produced, and through these channels, the coating solution or any preparation or emulsion or suspension will pass through these ports, and they fall onto the walls of the colloid mill. And between the rotor and stator, it moves and it comes out. So the main purpose of these grooves is to hold the feed material and to make it pass along the ports, so that by what about the uniform distribution of the emulsion preparation or suspension is being rendered. So this is how the rotor will look like. And if you see here, this is the component of the rotor. Can you see these are the ports? As I told you, these are the ports where the feed material will be held. And once it is coming into this area, it will pass along through this narrow elongated channels. This is how the industrial colloid mill will look like. And as I told you that colloid mill is a machine, is a size reducing machine, or a size reducing mill, which is mainly used for size reduction of emulsion particles present in suspensions, emulsions, or in coating solutions. So this is the information where whatever I have spoken or explained will be found in this information. If you go through, you'll have a clear picture. And let us see the pharmaceutical applications. It's mainly the colloid mill is the dispersion of solid particles within a liquid. It is frequently used to increase the stability of suspensions and emulsions, because once the particles are size reduced, thereby what happens, the preparation final product will be having a homogeneous distribution of the active ingredient throughout the preparation. So thereby what happens, the stability of emulsions or suspensions will be improved. And it is used for the formation of efficient emulsification. So you can all, when you wanted to have a emulsion to be prepared, so if you subject it to colloid mill, you will get a more robust, sufficient, smooth emulsion preparation, and you'll get good homogenization of the emulsion preparation. Okay, and mixing can be done through colloid mill. Then it is used to reduce the particle size in suspensions in a liquid, or to reduce the droplet size of the liquid suspended in another liquid by applying high levels of hydraulic shear to the process liquid. The reduction is done. Okay, so particle sizes of as small as 3 microns can be obtained by the colloid mill. So there are a good number of applications with this colloid mill, and it's mainly used in pharmaceutical preparations, especially for colloidal dispersions, suspensions, emulsions, etc. Okay, so those ointment which can be free flowing can also be used, but those which cannot be having a free flowability cannot be used. Okay, so those preparations which has free flowing nature, they can be subjected to colloid mill. Okay, colloid mill is usually in a number of industries, including food industry, beverage, pharmaceuticals, and chemicals. So it is ideal for small, medium, and large scale tablet batching systems. And it is the most efficient system for dispersion and homogenization of raw materials. Okay. And colloid mill can be sterilized because it is a jacketed vessel. So you can able to circulate hot water so that it can be sterilized. So it can be mainly used in the production of sterile products also. And if you see, it has a very high throughput with excellent grinding results. It is suitable for products of high viscosity range, high quality surface finishes for easy cleaning, and capable of operation under pressures up to 16 bars. Machine is a self-draining, infinitely adjustable gap settings between rotor and stator for control of particle size reduction. This is one of the important advantages of colloid mill, as I told you, that the rotor can be adjusted for the gap settings, and high value seal with wear resistant materials. Other materials and finishes are available upon the request by the manufacturer, and it has low noise levels. Coming to the disadvantages, it has no wide applications in solids. It's not suitable for solids, as I told you, and wear of the rotating plates. Definitely, for any equipment, wear and tear will be there. No fine grinding, consumes energy through still, though still dependent on some fact. No, so, however, it has very less disadvantages. Overall, the colloid mill plays a very important role in pharmaceutical industry, and we'll see some more equipment of size reduction milling equipments in the subsequent classes. Thank you.